Hello and welcome to this episode. In this video, I'm going to show you Numpy and PyTorch. But just to give you a heads up, I want to let you understand that after this video, the subsequent teachings are going to happen through screen recordings instead of the classroom experience that you're having here. And the reason is, just like I kept promising, we needed to learn all those things we've learned up to this point, just so we have the foundations right. And now it is time for us to actually start getting our hands dirty. And because Numpy and PyTorch are very important in the machine learning landscape, I'm going to spend quite a few number of videos explaining the details of how to do vectorized implementations of certain calculations using Numpy and PyTorch. So just in case you realize that the subsequent videos after this video isn't giving you the classroom experience, I don't want you to feel like it has ended. It hasn't. It is because we are going to get practical. We are going to do some hands-on coding. So I would want to code and record my screen and show you how things are done. And then after teaching you about Numpy and PyTorch, we will come back to the classroom experience as and when it is required. So to cut things short for you, what is Numpy, what is PyTorch, how are they related? So Numpy is basically a Python wrapper around some C code that has been written to help you do some vectorized calculations, okay? So up to this point, you know what a vector is. Now, if I have, let's say, a million numbers, a vector of million numbers, to add to another million, a vector of million numbers, in vanilla Python, you have to write a for loop, and depending on how well you understand Python, you might end up using a for loop inside a for loop, just so you can sum things up, okay? Now, what Numpy does for you and PyTorch also does for you is it helps you to do vectorized calculations, vectorized implementation of the common calculations that we do in deep learning. So for example, if I have a vector A to be equal to 1, 2, 3, and then I have a vector B to be equal to 4, 5, 6. Now if I do A plus B, what's going to happen is Numpy or PyTorch is going to do element-wise summation and then give me the resulting vector. So this is going to be 1 plus 4, 5, 7, and then 9. So you can see that it helps you to write code treating these vectors as though they were values that contained single data points, okay? But in actual sense, they are vectors. And so what Numpy or PyTorch helps you to do is to have vectorized implementations of certain common calculations that we do when it comes to neural networks. Now, I'm sure you're wondering why Numpy and then why PyTorch, and what are the difference anyway. Like I said, Numpy and PyTorch both provide vectorized implementations, okay? So they help you to do vectorized calculations. Vectorized calculations. And so your code will be more efficient and then it will speed up. But then PyTorch has support for GPUs with CUDA, and it also supports automatic gradient calculations, something called AutoGrad. I mean, for now you won't understand everything, but once we get our hands dirty and then we start coding, you understand what I'm talking about. But the take home from this video is that both Numpy and PyTorch, and I don't want you to be confused because probably you think PyTorch is supposed to be a neural network library, so how come I'm comparing it to Numpy? And the reason is, so the neural network aspect of PyTorch basically just builds upon the features that PyTorch makes available, which is so similar to what Numpy makes available. And you can code any neural network from scratch with PyTorch without even using the neural network modules that comes with it, but of course you don't want to build everything from scratch, so when it is necessary you use them. But the essence of this video and the subsequent screen recordings that will come after this video is to show you how to use Numpy and PyTorch to achieve vectorized calculations or vectorized implementation of certain common calculations that we do in neural networks. And like I said, PyTorch has support for GPUs using CUDA, and it also does automatic differentiation for you. So when we start implementing gradient descent, you understand that the way we learn how to adjust our weight according to the error is to calculate gradient, and that is the point where knowledge of calculus becomes very important, and not knowing calculus can be a limitation. But thankfully we have PyTorch, which is able to automatically calculate gradient of your functions for you, and so all you have to do is to follow the gradient descent algorithm, and everyone without enough calculus knowledge will still be able to do deep learning. So this is what distinguishes PyTorch from Numpy, but their APIs are very similar and they are highly interoperable. So you can convert a Numpy vector or Numpy array into a PyTorch tensor, and you can also convert a PyTorch tensor into a Numpy array, or back and forth as and when you want. And the reason Numpy is important is, in this course I will not just be teaching you PyTorch, I'll also be teaching you TensorFlow, specifically the Keras API of TensorFlow, which also makes use of Numpy a lot. And aside TensorFlow, Keras, and PyTorch, there are, all the tools we use in machine learning basically have got to do with Numpy. So if you are plotting graphs, if you are doing data frames with pandas, the basic data structure that most of these machine learning toolkits deal with is Numpy. So I will explain Numpy to you. After that, we'll go to PyTorch and I'll show you how they are interoperable, and then from there we can actually start coding neural networks. And at that point, we'll come back to the classroom teaching experience when it is necessary. So henceforth, expect screencast until further notice. Thank you very much for watching, and I'll see you in the next video.